Welcome to Cybersecurity Shall Be C-Level Priority, the podcast that puts the digital world to the test. Cyber attacks are on the rise, and data is the most valuable asset in today's world. But how can we protect what matters most to us? Drawing on the latest insights, effective strategies, and practical tools, we'll show you how to create a more secure digital environment. Because one thing is clear: security isn't negotiable. It's a top priority.
Hello, and welcome to a new episode of Cybersecurity Executive Matters, the podcast. Today, with Knut. Hi, Knut.
Hi, Nico. How's it going?
Today, we want to talk about an exciting topic, namely, what does open source have to do with cybersecurity? But before we start with that, tell us, who are you anyway?
Well, I am the product manager for product security at SUSE for everything that is called SUSE Linux Enterprise. And I am also responsible for the topic of compliance. And very importantly in this context, in the broadest sense, government interests.
Yes, an exciting topic, because actually my journey in technology, in quotes, let's say, also started with SUSE. Our school back then had a SUSE server, and those were the first points of contact. I actually got into cybersecurity by finding a vulnerability in the server and then eventually having all the passwords of all users in plain text. So I find it quite exciting today to start with the topic that also marked the beginning of my career in cybersecurity. Although it's not the topic today, SUSE has always been an exciting topic for me. But today we want to talk about the topic. What does open source have to do with cybersecurity? And you often hear, especially when it comes to open source, that open source is insecure, or that cybersecurity for open source is impossible. What is your stance on the topic? Is open source really insecure?
No, on the contrary. So my personal opinion, and this is not just because of my job, but rather the other way around, because I see it this way, I have this job. I can only say that the advantages outweigh the disadvantages. So there is nothing where there aren't somehow disadvantages. In every principle, there are intrinsic points where you can say, yes, that collides with other principles. On the other hand, especially when it comes to open source, there are many points where security actually, I would say, has an even greater chance than with closed source.
When we talk about open source, I always mention the topic of security. An important pillar of security is also the topic of transparency. I mean, we are all human. Humans make mistakes, computers make mistakes. And security is also a topic. With transparency, you can also create security, because if multiple people can look at it, multiple eyes, multiple strategies are applied, or rather, everyone has their own expertise, then you can inherently make something more secure. Because someone who says, I never show my code, I do it quickly in private, and no one knows what happens. That's why I think, especially when we enter this discussion, with open source, it must be clearly stated a major advantage of open source. And also the topic of security is, of course, the transparency that you have in the open source area. And this topic always fits well, that we move from security through obscurity to security through transparency. Previously, we always said, okay, we have to trust. And in the end, it's the obscurity and not the security. And open source is, for me, the essence, or actually the most important topic, the topic of transparency that I create, and thus also the security that I can create, because we can simply have multiple people look at it and also incorporate the expertise of several people. And it wasn't just developed by one person in a small chamber.
Absolutely. I mean, security by obscurity is fundamentally a bit problematic. On the other hand, there are, of course, things that we also keep secret. So I will definitely not post the private addresses of all our security-relevant personnel on the internet. I won't do that. Yes. And that's also clear, because trying to shield them individually would, of course, be a foolish thing. But yes, there certainly are things where we are very cautious about making our company's specific security concepts public. Where we say, okay, we select very specific third parties here. Honestly, we prefer German civil servants. They have a pension to lose, which is still really valuable. Thank you very much. And in that respect, they, so to speak, they immediately move into a criminal framework if they do anything there. And in that respect, we also have areas where we say, we try to keep the circle of people who know about it as small as possible. The best example of this are zero-day exploits. There is a procedure called confidential disclosure. It basically means that when a security researcher, responsible security researcher or hacker finds a security vulnerability out there and then communicates it to a manufacturer, usually then this manufacturer starts potentially also collaborating with other manufacturers. This is often the case with manufacturers in our situation. They then approach us. There are special NDAs that are so strict that within our company, the information we receive can only be shared with certain individuals. Yes, we are allowed to distribute. This is simply due to the fact that everyone deals with a number of devices, in our case, with which they communicates then into the risk. Every device represents a risk. Every communication action on a device represents an action. And if you minimize that, you already have a decisive advantage in terms of probability. That means we also try to, so to speak, keep a bit of secrecy there. Yes. In the best sense, so this procedure is internationally best standard and best practice. And it is also the case that the BSI advocates for this is recognized. They also say it's better than going public immediately and then the bad guys stop knowing about the matter. We at least hope for a time advantage in solving a problem. But in the end, it does eventually happen that such things become public, that we then go to the public, and as soon as it is public, we try to communicate as quickly, openly, broadly, and loudly as possible so that all our customers and partners and everyone else out there are immediately informed, because we also have an interest in ensuring that people using other products are safe. So the more people know, attention, something needs to be done here to check where there are secure updates. We are then very quick to respond. So this secrecy can sometimes only extend over a certain period.
The other downside of open source is, as we see in the example of XZ. This is also a chain. Even if one says, okay, many are looking at it, there are also corresponding processes. It can also not work, or it can be undermined. What is your view on this topic? So we know from this example, and there are other examples, that transparency can also produce the exact opposite. Namely, that people try to get into this chain and then take the opportunity to use it to introduce malware or harmful information into an open source product or an open source dialogue in order to be able to use it to advance their own interests and not necessarily the interests of everyone.
Yes, XLib was a very, very interesting matter. It cost me Good Friday last year. So I spent the entire Good Friday engaged in preparing the company communication, so to speak, and ensuring that as soon as we have the patches out, we can communicate as quickly as possible. The whole process was also a confidential disclosure, by the way. That means even there, we knew before many others that something was up, and then together with the very responsible, in this case, it wasn't even a security researcher, but amusingly enough, someone from Microsoft who started to take the software apart and discovered, oh, it's not behaving as it should. Then he went in and drilled down, why is it suddenly so slow? And he proceeded further and stumbled upon this entire process. But what must be said here is that an absolutely insane effort was made. So, someone had to make an incredible effort here. The security measures that already exist in open source to bypass them. And in this case, it was also very likely a state actor, or nowadays, state actors are also privatized. That means possibly a company that received a contract from a state. However, in such a case, these actors are hard to catch because they are usually protected by the state as well. They have an enormous amount of resources at their disposal because states are simply richer than subsidiary companies in general and can therefore mobilize a lot more resources. In this case, it was prepared for a very long time. Why? Well, such an investment wants to be protected. So if I go in there with a lot of money, with a lot of effort, I don't want to be discovered right away because I want to harvest it for a while in some form or another. So we don't know exactly why the whole thing there. One can only speculate it was an attack that was very cleverly thought out. So it was an attack on one of the main encryption technologies on the internet in the computing sector, SSH. This technology, this library is used relatively often for quite a lot of communications between machines, but also between machines and humans. That's why SSH is very, very central. That's why it also has a very high value because it's available on almost all machines out there. This type or this attack vector. But the interesting thing here is we also don't know exactly what was intended with it. The other thing is, to do this, they didn't come up with the idea to use the actual code to somehow infiltrate the library, but instead, they amusingly took a detour. They looked at it and, yes, how is it then in the open source GAUS area? Is it the case that you very, very often build on the work of others? That's incredibly efficient, it makes things cheap, and above all, fast. Yes, because I don't have to bother developing that part as well. And it's the same in this case that the SSH project then uses other libraries as well. Yes, among others, an encryption technology. No, a packer that essentially compresses software is used, and that is used quite often. And it's a smaller project that doesn't really develop at high speeds, but they used it because it was so inconspicuous. And at first, no one would think, watch out, you could intervene there. So in that respect, it was a bit of a side channel attack. Then they went in there and didn't just change the code because that would have been noticed, but they hid scripts, test procedures. Scripts had been hidden, which would have imported a code into it in the first place while the product is being compiled and built. And just imagine that they build scripts that are part of a test procedure, which then alter the build of another product in the main build process. And this product then ends up in the final target product. It's incredibly complex. And it also shows how complex it must be to ensure that something like this isn't quickly discovered. And in order to do that now, let's take it a step further. They essentially had to hijack the project. That means they went and put pressure on the maintainer until he no longer knew what was going on and then offered themselves as the solution, or someone who then messed around there. It took quite a while before it even worked. But it also shows how clandestine one must proceed to get anything into open source at all. So these opportunities where immediately if it's open and anyone can contribute, then I do something, then everyone sees it right away. So they had to proceed quite cunningly to make it happen. On the other hand, it was noticed. This is simply because so many people use and employ the software. And in this case, it even led to the fact that because it was open source, the person who noticed it could say, hey, something's not right here, and take a closer look. Yes, and then he checked, and in the end, he noticed this whole drama. So, in this case, well, it didn't help at all. It was just a matter of time, so to speak. But the more open it is, the faster it will be found. In this case, then it happens like this. For example, with us, the open source community around SUSE, OpenSUSE, the fastest distro, which was the quickest to, how should I say, implement the latest stuff, was affected. But our enterprise product was not yet affected because there are an incredible number of steps between the latest stuff from the community and our enterprise product. Yes, where checks are also made, where tests are conducted, and so on. And that also increases the risk of being discovered by an attacker. In this case, the open source principle, so to speak, helped a lot. If you now imagine the same people had tried to attack a closed source provider, which also exists, then in the end, if I now notice, wow, something in my closed source operating system is not fast enough, then that's it. Then it's just not fast enough, but I will never be able to find out why. In that respect, it would probably have been much, much harder to discover. Yes, because the number of eyes looking at it is simply much fewer. That's something to mention. But an exciting thing, of course, we also started doing a lessons learned in our company. We developed a very long list of ideas on what can be done. By the way, not only our company, but also other companies, which I cannot discuss further now, had ideas about this. Some of them are even quite eerie, where I had to say, hopefully the wrong people don't get their hands on it, because it might also help in an attack. On the other hand, I am very confident that in the end, overall, yes, the probability that something is discovered is much higher with closed source, and the probability that there is something in it at all is the same with closed source as with open source. So there are bad guys out there who come up with bad ideas and do their thing.
Thank you for your insight. What I also find super interesting is, as you mentioned, the way all of this happens, it must have been state actors, because the time, the resources, the money, not everyone can do that. A little tip from my side, there is a great documentary by Simplicissimus on the topic, so I'll gladly link it. Feel free to check it out. It goes a bit deeper into the subject. I think what this always shows, and you also mentioned it at the end, is that in the end, it doesn't matter whether it's open source or closed source. The same thing could have happened with a closed source situation. But you can also see here the effort involved, as it happens here, especially in open source, with this approach of putting pressure on the person responsible so that eventually they define a deputy or a replacement. And then the person, they didn't implement it immediately either, but waited for months, so to speak, to gain trust before anything happened. This also shows a bit how impressive the topic is. The question I have about this, or that I would like to ask you, is whether you also see that quick patching, as it is happening here, for example, through the community, is indeed the right way? Or do you think that sometimes taking a step back and reflecting more on it, doing a lessons learned, what happened there and how could it have been prevented, and only then release the patch, is that the right way?
Good question. Well, I would say, first of all, you have to somehow say that you can do this in parallel. Yes, so I'm not dependent on doing one thing after another here, but rather, on the one hand, you can say, okay, now people are looking at it. In that case, it even went so far that a step was taken back, meaning the code was essentially rolled back. Then it was reviewed again and then rolled out again. But of course, after that, it was... So I think it became one of the most closely monitored codes in the open source world, because now a lot of people have definitely looked at it. So in this case, it's not an either-or situation, but rather both. And of course, a lot of other people have been thinking about it And maybe some maintainers out there have also asked themselves, have I been pressured to? And because it could be so open and was discovered so quickly what was actually happening, since the steps, the communication within the developer teams were open, that's why people could also... I think the blog you described, I also read it, come to conclusions so quickly and so well, provide explanations. That was, of course, a great thing again, because a lot of people learned a lot from it. And I also believe that certainly one or another closed source operator or manufacturer might have thought we should also check somewhere on our end.
What I always find so impressive, and what many people don't even think about, well, I don't want to bash closed source or open source, because I believe both are super important and both have their right to exist. I also said at the beginning, the one in closed source doesn't always mean just one person, but also an entire company, which also sets things in motion. I wanted to correct that. But what I wanted to say with that is many closed source also uses open source components. So I recently listened to a podcast about the topic of software bill of material. This is also an exciting topic. If you try to get a software bill of material from some software with which open source components they come up with, and sometimes only 10% of what they actually use, because they themselves sometimes don't even know where all the open source is being used. I think this example also illustrates that. So for me, open source always has the charm that you don't just stand in the corner. And of course, I would say even closed software manufacturers use open source because you don't always have to reinvent the wheel. And for me, that's also the great strength, even in the open source area, to say, okay, there is already something that works. Why should I develop it myself? The other point is, to return to the question, this quick patching and rapid response. For me, it's always a story where there is no right or wrong answer. I think in this case, it went well as it did. It was quickly brought to the public so that people were aware of it. There were also quick initial patches on how to respond to it. On the other hand, I also see the great danger that when something happens quickly and perhaps too hastily, you might not have analyzed everything 100% and then overlook something. That's always a topic for me. And the other point I have seen with open source is who actually provides the security patches. So who has to do it now? Because often when we talk about open source, yes, we also talk about the fact that behind the operating system, there is also an application, and perhaps the application itself. Even there, I would say it works particularly critically with such interfaces and then perhaps no longer functions. I know this, for example, from my previous company in transmission technology. There were many management systems that were based on open source. And from a security perspective, I always fought with the manufacturer and said, guys, there is now an update from the operating system XY. Let's take as an example, Red. There is now from Red a security update. Why can't we implement it? And then the problem was always, yes, we can't implement it because our application layer just, the components can't process it like that, or there are problems, and the whole thing needs to be tested first. And so on. And we are talking about several million in the communication sector, what such systems cost, which are also 30, 40 years old. That means, of course, one must also consider that open source is not the cure-all. When it comes to the topic, especially regarding security, doing everything quickly, because in the end, you always have to see it in context. Where's the system being used? And for me, open source and closed source face the exact same problem. You have to think about how you use it. Which path do I take? And sometimes the path of going back and analyzing it is the better way, rather than quickly releasing a security update. And in the end, the application just doesn't work anymore.
But we have a very, very fundamental problem there. Problem, and one might be tempted to make quick radical leaps, to somehow move forward. But I advise against that. As you already said, open source is incredibly fast. And yes, that's why more and more closed source players are now considering using open source. Why? Because with closed source, they simply aren't as fast anymore. If they now get the idea to take everything that's out there in terms of open source, available to everyone, and rebuild it as innovation, then they would have to throw an insane amount of money at it. And the next thing would be incredibly slow, because there simply isn't enough personnel on the planet, as they are all busy and knowledgeable. And you can't bring enough new talent into the world to meet the demand needed to somehow replicate it. And I also believe that the closed source sector is increasingly coming under pressure simply by nature. That means, in my view, there is even a certain displacement happening. Closed source and open source is now, how should I say, the dominant principle. Already long in the shadow. When I look at where open source technologies are now embedded everywhere, just where Linux is found everywhere, even an iPhone has it somewhere in the background on a chip as firmware, which is dedicated to doing something specific. Running Linux, it's mind-boggling, and I sometimes find it very amusing. I also occasionally talk to people from politics, and politics can sometimes be a bit slow on certain matters. And they think of open source as some kind of hobby thing or something, which is nonsense. Because many, many open source developers work in companies, and open source projects are run by companies. We also once took the step of buying closed source software for the entire company and then making it open source, like NuVector, for example. Also, Runchow with us? Yes. That means we even ended closed source, yes, and made something open, yes. Things are then much, much faster. Yes, and of course, other security processes cost time, and you simply have to bridge the gap in between. One of these tasks that we now have, for example, as an enterprise-oriented open source provider is exactly that. Bridging between the speed of development out there and the speed that, I don't know, a tanker like a large corporation has. And here, for example, banks, they have to be very, very conservative and slow in their approach. And on the other hand, for example, states, which also cannot just whirl back and forth easily. So you can see at the moment that speed can sometimes be difficult there. And I am quite glad to be here in Germany and to know through my work that large authorities on which many fates depend proceed slowly and deliberately have test procedures. But in highly regulated industries like banks, for example, they have to obtain certificates and go through approval processes, and they can't always switch quickly. But they still need security updates, which are then integrated into these products before features. And this is exactly the kind of task our company at SUSE is fulfilling now. Yes, we call it long-term service pack support. I must say, it's not exactly cheap because we have to maintain parallel structures as it is labor intensive, but that's where the advantage of a company like ours comes into play, where we build bridges between the speed of the open source world, which is sometimes breathtaking, and on the other hand, the deliberate, cautious, slow, and thoughtful approach that is also needed. And that's exactly where companies like ours and others can help to find this middle ground. On the other hand, banks also benefit from the fact that patches are available much, much faster, that they can now adopt new technologies with new projects, which are then backward compatible with what was there before. But I also try to explain it to people like this. In the past, patents were invented because the secrecy was a brake on technological development. Every craftsman had their own, or everyone it started, with such manufactories had their own secrets in the production methods. Back then, these were companies. Princes understood that they had the say. Princes understood we have to do something so that they can exchange ideas. So we create the opportunity, go public with it, and in return, you get a 25-year monopoly. Others can then learn from it and further develop it. That worked quite well. But nowadays, the speed of innovation has become so high that it's no longer worth applying for a patent out there, because it takes 1 to 2 years for it to be enforced. And 1 to 2 years in the industry I'm involved in is an eternity. Yes, by then, features are already miles ahead somewhere else, and then you can't do anything with it anymore.
Maybe to round off the question, because I always find this a super important topic. Now, you've explained a lot about how you do it. What I would be interested in is, how do you feel about the topic of who decides or who has the responsibility at all? Security patches. Because that's also a topic for me. We've talked a lot about it. There have been, let's say, incidents in both the open source and closed source areas. Open source has the advantage, of course, that it is sometimes very fast. Also, when it comes to patches, we've already talked about how speed might not always be good, because you should first take the time for analysis or to look at it. But for me, the question is also an important one. Who decides or who then takes responsibility for the security patches?
And here it is such that that responsibility must be distributed. So we as manufacturers can imagine whatever we want about how our customers and clients, because we also have partners in between, will use our products. And a lot of the security risk is determined by the purpose of use. We cannot know that. Everything we can do is to create transparency, communicate comprehensively in a timely manner, and disclose the connections. And then other people who are familiar with the detailed risks and usage scenarios need to make decisions and weigh options. And yes, so that there is, one is, of course, in a certain way also dependent on expertise, on a wealth of experience. On the other hand, I am increasingly coming to the conclusion that one should also start, so not only to use qualitative risk management methods, but also quantitative methods that go a bit beyond classifications like high, low, medium, or something like that. Because sometimes such a consideration, which is behind it also, which you are now alluding to, is incredibly difficult. But there are general mathematical principles. If I get the idea to secure 5 lines of code with 50,000 lines of code, and I, as a product manager, know that every line of code is a risk, sometimes it's just that the risk works or doesn't work, and sometimes it's a security risk, then that is initially a critical decision, and that must first become clear to one. And with the multitude of factors that play a role there, people are often overwhelmed. It must be clearly stated people are naturally poor statisticians. We make poor decisions based on probabilities. Entire industries live off this. Lotteries and casinos thrive on people overestimating their abilities. And I can only advise against playing in casinos out there and thinking that one could estimate anything, so to speak. And also in the field, in the stock sector, the superiority of mathematical systems over individual decisions has now been proven. You can see that directly. So mathematically controlled funds out there are significantly more successful in the long run than, so to speak, gut-driven or knowledge-based or human decision-led funds. And similarly, I think the development in the field of security is going that one begins to use qualified statistical methods. A good example is fault trees or attack tree analyses. And it is always said, yes, I don't know the probability, that's true. But yes, it is estimated, but the mechanics between the individual probabilities are then again mathematically precisely related. And so such a technique helps me to bring my own knowledge, at least, as far as I know it, into application in a mathematically clean way.
Now, it is the case that we have talked a lot about the risks associated with open source. I would like to turn the coin and also talk about the advantages, or rather, what we have already hinted at. Open source and closed source, they are actually quite similar. Now, it is the case that, especially in new regulations, the topic of open source is also more strongly included. So whether we look at things like DORA, NIS2, and whatever they are called, especially from the regulatory topics, open source is becoming increasingly important and relevant. And what personally pleases me is that transparency is the main issue that people should now address, where they want to think about whether it's a software bill of materials or generally dealing with the topic of open source, where am I using it, which libraries, and so on and so forth. What is it for you? a best practice approach that you also like to share with companies when using open source? Would you say you can apply exactly the same, let's say, security methods or the same security topics that you use with closed source just as easily to open source? Or do you say for open source, one should definitely think differently, especially when using open source as opposed to traditional, let's say, security methods, as it is with closed source?
I can't fully answer that question yet, but I would initially assume that I can actually do everything I can do with closed source as a user, as someone who uses it as a consumer, or as someone who manufactures a product with it. On the other hand, I have even more possibilities. With open source, with closed source, I have to rely on everything that a manufacturer tells me in the end. I don't get more than that. It might also be that I don't trust it, but what can I do with open source? I can go further if I want to. I can conduct code reviews. I can apply my own evaluation criteria. For example, if state actors out there are using closed source software, then they basically have to more or less go along with the update cycles of the providers. And because it said that there's a security update in there, we have to trust that it's actually in there. And then, of course, we have to go, and many say, well, we conduct deployment tests beforehand. This is now also being required, so that I, first of all, test the patch. Does everything work? Is everything still running? But now large, for example, state actors with many resources are already doing this. They have such cycles and testing procedures. Everything is tested first before it is even rolled out. Clearly, so I can do that too. However, with open source, I can pass it on. There is an interesting approach from Zendes, the Center for Digital Sovereignty. This is essentially an open source program office initiated by the federal government, which is also established in the form of a GmbH. Yes, was established, and they are now pursuing very interesting approaches. They are now saying we are providing source code repositories for state projects and also conducting their own security assessments. They would probably find it difficult to implement this with a state-owned closed source product. Yes. If you apply a lot of pressure, maybe even a giant like that would open up their things, but only under NDA or something else. They can present everything quite openly, collaborate with the Fraunhofer Institute, and develop metrics to evaluate the open source projects. I find that a super exciting approach. We also got into a conversation with them for the second time and became very attentive because, of course, we also ask ourselves, can we adopt principles that they have developed? Can we, for example, incorporate this into our production cycles as well? And can we then engage in an exchange of experiences and benefit from each other now? And to be honest, when it comes to security and there are things that improve security, I am also very happy to work wonderfully with other open source providers, whether it's Red Hat or Canonical, because we gain nothing from having insecure source code, and we can collaborate freely there because we have no secrets. We can't have any secrets because no matter what we change, the competition sees it immediately, and that's also a positive approach. And especially here, more is possible. You have to be able to afford it, but the advantage here is that the entire community benefits from this approach. That means even if Zendes is tinkering away, funded by the federal government, in the end, someone in Sri Lanka might benefit from it. Closed case, right?
Absolutely. And I think what one should always convey to our customers about open source is that they should increasingly pay attention to the issue of transparency, that you first need to know yourself, what do I even have in the company, which is now also required by legislation. But in terms of security measures and security methodologies, I don't see any differences. So there, the same measures can be taken as with closed source. I believe we have some catching up to do here, especially regarding transparency, because many companies don't even consider where all the open source comes from and is being used. A prime example is Microsoft, as you already mentioned. Microsoft Teams, for instance, try to really get a software bill of materials to see how many open source components they use. It's really extremely interesting to see. how many components are open source. But where I would like to go now, we already talked about it in the preliminary discussion. Where do you see the future of open source, especially in such matters? I'll throw in a few. Buzzwords, zero trust, AI, and so on. That certainly changes the open source world as well. How do you see that? Where do you think the open source world will develop with such topics? I mean, there is already something like Kubernetes security, which is also open source based and is already in this area. A lot is already being done in cloud security, also concerning open source. So even in the security sector, for example, in this area 7, there is already a lot open source tools where you say, okay, you can, of course, also take advantage of open source combined with new technology like AI to provide security, that is to offer security tools. That's also an exciting trend that you see more and more now.
Yes. So as I said, I already mentioned it earlier. We acquired a company in the USA called NuVector. They developed security software for the Kubernetes sector. We thought that with this, we could quite well expand our product portfolio around Rancher. Rancher is a Kubernetes project, a management platform where you can control Kubernetes. For those who are not so technically familiar, Kubernetes is software that allows me to move things like containers around in a modern data center landscape. And what are containers? Containers are essentially a virtualization technology, but I no longer need a complete operating system environment. Start up and run as a virtual computer, but rather virtualize only a part within a computer. So essentially, a set of applications and the associated libraries, specifically virtual. So also somewhat separated from the rest, controllable. Yes, so to speak, operate. The advantage here is that containers can be started up very quickly. This is in the millisecond range. A virtual machine, on the other hand, can take minutes to start up. Additionally, it consumes fewer resources, requires less storage space, and similar things. However, it is also a bit more difficult to shield. That's where products like this come in. Like NuVector with us now. However, there are open projects out there. That's a nice thing. You can watch each other develop and learn from one another, and accordingly expand functionalities. This in turn significantly accelerates the overall pace of innovation, and especially with containers, it is now important to use such tools. And here, also with Zendesk, they provide curated containers, as far as I know, and they somewhat relieve state actors of the task of assembling and evaluating the projects behind them. You can use that as a bit of guidance. In larger companies, this is already being done anyway. But yes, I agree with you. Sometimes in companies, speed takes precedence over security, and then many people quickly don't know what's inside such a container. And the danger here is, so if I typically use a Linux operating system, then we have curated it. Our libraries are included in there. Our security experts have looked at it. Our tests and regression tests have been run over it, the automated ones. So if I have such containers, they usually contain completely different sources for the software. And if I don't rely on an enterprise Linux like ours, I have to ensure security myself. And I have to start curating it and to look into it. But and I notice this with customers as well, the compliance departments are becoming very, very alert, starting to use special scanners and saying, I'm going to scan over it now. And they regularly experience surprises there. And then they ask, what have you suddenly got there anyway? Where did you get it from? And where does it actually come from? And these questions can sometimes be a bit difficult. And here, the legislator has now intervened, and in the Cyber Resilience Act, which will be fully operational by the end of 2027, I believe, December 11th. It is mandated that all SBOMs, meaning all those who provide digital components, stumps, products with digital components, such SBOMs, and so, how should I say, lists of the software that must be provided, which is built in there, so to speak, and these lists cascade very strongly in the open source area and must be maintained. But then you can trace through these SBOMs where something comes from. And then such scanners can also better target and, for example, identify security-relevant code areas.
Perhaps one final question for you personally. Do you believe that open source will dominate the future of cybersecurity?
I would even go further. And that concerns my career choice and why I am now working for the company. Yes, because I certainly like having a secure job and work in a prosperous company that makes a lot of money, so I can earn a lot of money. I would say open source is the thing when it comes to software. So there is certainly closed source areas where one can say it will survive, but fundamentally the speed of innovation will outpace everything in the software field. So now, well, you can listen to me or not, I work for the company, but I could also work for another. I can only say I consider this speed of innovation that is inherent in it, together with the other advantages, broader personnel base, better documentation, up to the point that the source code itself is a form of documentation, then I can only say the advantages are so significant that I think closed source will have an increasingly harder time against it.
Thank you for your personal opinion. I was very pleased to have you on the podcast today. I believe we were able to hear a lot about the topic of open source and especially your personal opinion. For me, it's always important to hear other opinions as well. I would say that was it for this episode of Cybersecurity Chef Sash, and we'll hear and see each other next time.